All right. Hello there, 8th graders. Last week was pretty exhausting with Module 7 and solving equations. So this week we're going to try something a little less complicated, but you do still need to show your work. So we're going to be looking at our volume. It's in Module 13. So volume is basically the amount of space that an object takes up, and it's kind of inside the object. So the amount of space inside the object. Your examples of volume are filling up a pool, filling up a popcorn box, filling up a can of soup. You might say filling up a glass of water. Keywords there, you are filling something up. So volume fills up the inside space. That's kind of your keyword when you see a word problem. That might be one of the clues that it's a volume example. It's also measured in cubic units because we're multiplying 3 dimensions together. So if you remember from volume of a prism, it was base times width times height, and that would be inches times inches, which turns out being inches cubed. We'll talk more about that as we get into our examples today. Hopefully I won't forget to include the units. Please also make sure you're taking notes as we go through this video. If you need to pause it, to rewrite something, or to rewind it, if I say something really fast and you don't understand, feel free to do so. All right, moving right along. Today we're talking about the cylinder, and the base shape of the cylinder is a circle. Hopefully you knew that part. So a cylinder is basically 2 circles connected by straight lines. So if you're drawing it, you draw the 2 circles and connect the lines. Connected by 2 lines. You always want to look for either the radius or the diameter. Radius is halfway across your circle. Diameter is all the way across. If you get those mixed up, I always remember diameter is a longer word than radius, so diameter is going to be all the way across. The radius is half of the diameter, so if you're ever given the diameter and you need the radius, you just cut it in half by dividing by 2. When we look at a circle compared to a cylinder, the area of a circle is pi r squared. And we start with a circle here, pi r squared. If you watched the video with the little mouse, that's just a series of circles being stacked up, kind of like the cookies are stacked up. So the new dimension in a cylinder that's not in a circle is the height, right? Instead of just a flat circle, now we've got a height in between our 2 circles. I'm going to erase those. And then, so here's your formula for that. It's like the area of a circle, but it also includes height. So pi times radius squared times height. Pi, you can substitute 3.14. Radius squared is radius times radius, not radius times 2, and then times the height. Couple of key reminders for the height. It's always the distance between the 2 circles. So you might want to make yourself a note. That's between the circles. So for instance, in this one, the height is clearly the vertical up and down part of your cylinder. But when your cylinder is lying down, this is not the height. This is the diameter because it's on the circle, and the height is going to be the length between the 2 circles. So sometimes the height may be called the length if your cylinder is laying down. I dropped my calculator. All right, so I think that's the gist of the formula. You do have to use radius, so if you're given diameter, cut it in half before you put it into the formula. All right, so our first example is how much water will this vase hold? So we're filling up the vase with water. Always start by writing that formula, pi r squared h, and then we can substitute right in place of pi. We'll put its decimal form, and our radius is 3. I like to write it twice so I remember to square it, and then times the height, 13 inches. So again, this is where we're doing inches times inches times inches. And then you basically plug that into your calculator. You can do the 3 times 3 in your head and type that in as 9 if you want. And I got 367 and 38 inches cubed. I'm going to double check that before we move on. and that looks correct. So again, we just substituted right into that formula. We were given the radius and the height. Simple, easy peasy. Moving forward. Of a drink in a styrofoam cup with crushed ice. So, same thing. We want to fill it up. We're looking for the volume. Pi r squared times the height. And substitute right in. You do have to pause for a second here because when your line goes all the way across the circle, that's the diameter. So I need to divide this by 2 in order to get my radius. So that's going to be 2.5. So just slow yourself down when you see that diameter. And then we would multiply it times the height, which is 11. And again, I like to write that radius twice so that I don't accidentally type in radius times 2. Radius squared is radius times radius. And I put that into our calculator and got 215.875. I believe a lot of your examples may say round to the nearest tenth, so technically I could round that up to 0.9. And it's inches times inches. So inches cubed. And I always say volume is cubed, so you remember to put that little 3 at the end. If that comes in handy for you, give it a try. Double check my calculations. And let's try another example. All right, here we've got a horizontal cylinder, but still a cylinder, so I can use the same formula. Pi r squared h. In this case, it's halfway across, so is that the radius or the diameter? Yeah, that's the radius, good job. And then in this case, since it's from circle to circle, that's going to be my height. So even though it's lying on its side, that's still considered the height. So pi, radius, radius, height. Then I'm multiplying that all out. All of these problems actually had inches for the units. That's not, it doesn't have to be inches, so pay attention to whatever units are given in your and 72 hundredths inches squared. I'm going to check that again. And that is looking like it's correct as long as I copied and typed in everything correctly. All right, one more example. Not too bad. Not sure if you can read the numbers, so I'm going to write them bigger. We've got a cake pan that has length, width, and height given, or base, width, and height. And we've got a cylindrical cake pan that has a diameter of 8 inches and a height of 2 inches. The question is asking which one is going to hold more, this pan or 2 circular cake pans. I don't really care what shape you make it in. Let's just eat cake, you know? But since this is a word problem in the book, we'll try to play along and find the volume of the rectangular pan using base times width times height. And that would be 13 times 9 times 2. I got 234 cubic inches. Check my work there, please. And then since it says 2 round pans, or 2 cylindrical pans, I'm just going to multiply my whole volume formula times 2 in the very beginning to double that, so I have 2 cake pans. And then it's, if the diameter is 8, cut that in half, the radius is 4. So, let me get my pi in there. 2 times 3.14 times 4 times 4 times 2 for the height. And you'll notice me going back to using the X for the time sign instead of the dot like we did last chapter, just because with the decimals and stuff, sometimes the X is a little bit better for separating. That dot sometimes looks like a decimal, so just be careful. So 3.14 times 2 times radius times height. And I got 200.96 inches cubed. Let me try that one more time. And that looks right. So which will hold more cake batter? We use the rectangular prism instead of the 2 round pans to bake your cake because we want more cake. That's it for volume of cylinders. Try your classwork, and we'll move on to cones next. Have a great day.